Cool. Take it away. So the focus of this panel is going to be on building trustless scaling solutions, particularly around security and auditing. I think, I guess for those of us who are new to the event, Alex, Daniel, Barry, would you like to briefly introduce yourselves? I guess Alex, starting with Alex.
Yeah, sure. I hope you can hear me now.
Yep.
Yeah, I spent a significant number of years on EVM research, mostly at the Ethereum Foundation. And, regarding Polygon zkEVM, at Spirit, we assembled a number of different teams to conduct review, and I've been participating on the EVM side, mostly on EVM compatibility questions, how the zkEVM would compare to mainnet, and if there's any differences, what kind of risks those could pose to, on multiple facets, including languages. I think that's like a short intro.
Cool. Daniel, do you want to go next?
Yeah, sure. Daniel from Polygon 0. So we work on a separate zkEVM, which is focused on type 1 compatibility, and also working on related technology like Plonky 2 and now Plonky 3.
Cool. I guess I also work with Daniel, and then last but definitely not least, Barry. Do you want to briefly introduce yourself?
Oh, can you hear me?
Yeah.
Hey, I'm Barry. I work on a whole bunch of like zk things, and including I had a lot of fun working with Jordi on the early stage zkEVM stuff. So I'm happy to be here today and chat about all this.
Cool. Well, I think we can just jump into it. I think it's safe to say, Jordi, from conversations that we've had, that security is. Oh, yeah, Chris.
Yes, I'm sorry, but we do have Vahe now.
Okay. Vahe, do you want?
Everyone is there
now. Vahe, do you want to introduce yourself? All right. Yeah. So I think it's safe to say, Jordi, from conversations that we've had internally at Polygon, that security has sort of been the guiding principle of the development of the zkEVM. And so I wonder if you could just talk at a super high level about the philosophy and the perspective around security and auditing and sort of building a system that fundamentally protects user funds. So we'd love to hear.
Yeah, there has been probably it has been the biggest challenge of the whole system, because these systems are really complex, and there is a lot of new pieces that are built on top that are built for this. So one single piece that goes wrong, and the system is just insecure, and this is really, this is really problematic, and it has been difficult here. When we face insecurity, it has been just trying to isolate the things that can go wrong, and just trying to find the right mitigations for the things that that can go wrong. So in the case of Polygon, we just distinguish like four things that can go wrong. One is smart contracts. We know very much about what can go wrong in smart contract, and this is one type of things. The other is the correctness. This is really bad. If the correctness of the proof, you are proving something that's correct, but this correctness goes to that some balance is wrong. This is really bad, but we cannot do much about that. The good things on this point is that because it's Ethereum compatible, we just leverage on top. So we just run all the Ethereum tests, so and we're passing all the relevant Ethereum tests there. There's more than thousands of tests there. This gives us a good confidentiality that there are no correctness errors, or at least it's difficult to get the correctness errors, because all the tests are passing, so everything is working as it's supposed to be. This is not exactly, so there are some exceptions, and there are things that can go wrong, and we found something at some point about that we will be very decision. That's really difficult. The one that's really easy is the soundness error. Soundness error in the prover is just for having some constraint. This is really easy, and this is what we can go wrong. And here the mitigation is was proposed by Vitalik at some point. But there's two mitigations. The first is that if you are running if you have a priority prover, so if you are running the proofs, you are not going to prove something that's wrong. So this is difficult, but the prover may stop, or if you want to have a decentralized system, you need anybody to run a prover. And here is where maybe if two provers go from the same state with the same transactions to different states, then you can detect that automatically in the smart contract and how the system. These two mitigations are good for this soundness, which is really easy to have a mistake. And the fourth one is more technical, but it's like that you just stop, the prover just gets stopped because you cannot generate the proof. But this is just, the mitigation is very easy because the system just stops at 7 days in the time mode. You just upgrade the system and you continue. So here, so this is how the things, and that's why you feel comfortable for launching. But again, security is, you never have the 100% security that the system is correct.
Right. So we sort of have this framework where errors can be either correctness, soundness errors in the prover, and then smart contract bugs. Is that sort of safe to say?
Yeah, and then the other is that the prover that you are not able to generate the proof, which is
okay. So so the liveness issues. Okay. So given that framework, I guess it would be really interesting to hear from Alex and then Vahe. We didn't get a chance to hear your intro, so if you could provide that. But just like what the experience has been auditing different parts of the system, sort of within that framework of different errors. Like how do you approach auditing for correctness? How do you approach auditing for prover soundness? So it'd be cool to sort of hear your perspective.
Yeah, thank you, Brendan. Sorry, guys, I had some issues with the video, so I skipped the intro. So I'm the CTO and co-founder of Beregszaszi. We did the audit for the zkEVM. So about the question, I would say that with the soundness, I wouldn't say that there is a lot of things different than testing for completeness and soundness. I would say that it's about the approach that you take in auditing the different layers of the zkEVM, because basically it has like, we can call it like hardware layer, firmware layer, and application layer. And one thing that we're trying to do is that when further we go down into the layers, for example, when we were auditing like hardware layer, we're trying to use also some toolings there, because like static analysis and like dynamic analysis, trying to write like a small tools, some toolings that will help us out, because basically that's where almost everything is connected with some edge cases, and like the bigger the coverage, the better. And you have a lot of, for example, auditing peel state machines, you have a lot of constraints and a lot of assumptions. It's hard to just remember all of them sometimes. So yeah, it's better to use some toolings in that kind of situations. And also like the manual review. It's always the manual review for every layer that you do. I mean, you sometimes you cannot find edge cases that will be found programmatically. You just need to watch them. That's pretty much it.
Yeah, I would say a single word answer to the question. What did it felt like? It felt like scary, like extremely scary getting into it. Because the zkEVM team has built a number of languages, a lot of tooling, a lot of different parts, and they were also constantly improving the system and conducting an internal review. But they were super helpful in setting up trainings, training workshops, and being available to answer any kind of questions when looking at any of the different layers. I think what has been challenging, of course, is the different layers, what kind of understanding and knowledge and background those different layers required, and then the connection between the layers. I think generally it has been, initially it was like extremely scary, but as you get into it, you build up confidence, and especially the fact that Polygon zkEVM is able to execute most of the Ethereum state tests. That was a reassuring fact, and there was in fact a good starting point to dig deeper and see why any of those test cases would have been disabled. There could have been a number of reasons, mostly because the test cases required gas higher than what the prover would support. So even just investigating from that level down, it is possible to find a number of different issues. But I think generally we had a number of different teams looking at the different parts. The state machines have been looked in isolation. The EVM instructions have been looked in isolation, and then there is like a stage where you try to connect these dots together. I think tooling is we did try to invent some tooling, especially for the peel layer. But I think given how nascent this technology is, there's just not enough tooling. What I've seen to be somewhat useful is pattern matching. And once you identified a given issue, which may look like something you want to investigate further, I think some of those patterns were emerging in multiple parts. So yeah, I think pattern matching is when you look at such nascent technology, that's more useful than trying to invent complex tooling.
Cool. That makes a lot of sense.
I want to add that I definitely share the sense of scare that's the thing. Yeah, I was just trying to be more pragmatic on the answer, but yeah, sure. About the tooling part, so was a lot of pattern matches, like variant analysis thing, of course. Yeah, I mean, creating complex tooling here, I believe, hardening and overkill rather than using like variant analysis techniques.
Cool, makes sense. So Barry, we already heard that your conversations with Jordi sort of served as the genesis for this entire project, and you guys are longtime friends. I'm really curious to hear from both you and Vitalik, sort of how the EF sees its role as like shepherding and stewarding these protocols and projects into maturity and into production, and particularly in the context of security and audits.
Sure. Thank you, Brendan. So yeah, the way I think about this is that like there's a lot of different layer 2s that are sort of like working to scale Ethereum. And one thing that I would really like to see on the security dimension is more collaboration between the different layer 2s. I feel like a very nice security parameter we could have is if we had a zk rollup that also had a fraud proof. And a fraud proof was just like, the fraud proof was one of the members of the Security Council, for example. And if the fraud proof disagreed with the zkP, then we would have to fall back to the Security Council to like decide and break the tie. I think that this is a very nice kind of underrated feature where we have all these teams working independently, but I would like to see eventually everyone sort of joining forces and working together. Because at the end of the day, like you get a lot more security by having a roll-up with like a fraud-proof and a validity proof.
Cool. And then Vitalik, it would just be really cool to get your perspective.
Yeah, I mean, I think in general, like in development of all of these new technologies, like the Ethereum Foundation tries its best to play a supporting role, and at the same time, try to avoid picking winners in the kind of project and application space, and try to support projects that kind of uplift the entire ecosystem, and kind of play those more like supportive tasks that are valuable things across the entire ecosystem that are more kind of coordination related, that would make much less sense for each individual team to do on its own and so forth. Sometimes that has meant writing and contributing to specific pieces of code, though I think even there, like we've been striving to not have the foundation dominate that, and bring in contributions from
other layer 2 teams and some other teams. Sometimes that involves being supportive on the security and auditing side. Sometimes that supports other things, but like generally, yeah, I'm trying to kind of foreground the people in the ecosystem that are doing all of the amazing work as much as possible.
Cool. Very cool. And so, Daniel, it would be really interesting to hear from your perspective, being internal to Polygon, how sort of the culture of collaboration around security and auditing actually functions. I know that you were one of the participants on the internal audit of Flock. So yeah, it would be great to get your perspective.
Yeah, it's been a really nice collaboration between Polygon Zero, the Hermes, and the Miting team. So together we're sort of the zk side of Polygon. So my involvement in Hermes zkEVM was fairly small, but yeah, one thing I was able to do was help to do an internal audit of the Flock code, which was very, very interesting to learn about and see how they were doing things. I'd say we've just had a lot of really good discussions with these internal teams about what the right approach is, especially when it comes to sort of training wheels or backup layers of security. What sort of backup layers can we come up with to make sure that worst case, if there is a soundness bug, then we have some kind of fallback option, and it's not just game over.
Yeah, cool. And so back to Jordi, it would be really interesting to hear about your sort of perspective on the roadmap for what training wheels we have now, like what the process of taking them off will look like, and sort of like the end state that you'd like to get to.
Well, first of all, let me point one thing that just to answer a little bit Vahe here, and is that all the audits are public. I don't know if the last ones maybe are in a draft mode, but if they are not public now, they will be public like tomorrow. You can check that in the repos. So on the repos, they have a directory with the audits. And, I mean, it's full transparency here. I would recommend all the rollups, especially the zk rollups, the space to read those audits, because as the people say here, that there is a lot of patterns, a lot of things that were discovered, and you can learn a lot just reviewing those audits. And I think it's called for the security in there. And of course, we are absolutely open. I mean, I think collaboration is key here. I mean, sharing and being transparent in these audits, I think, is the one step in that direction. For the future, we just started, I think it was last Friday, a bug bounty program. I think that continuous auditing is fundamental for here. We will continue to, we plan some upgrades, as I mentioned, just including this pre-compiled smart contract. So this will be complemented with some audits, and we probably will do some re-audits of some of the parts. So we already have identified some of the pieces that maybe should be more checked more closely, or just talking with different auditors. Here we have a good feedback of what are the more dark zones and clear zones, and what are the concerns. And we are sharing a lot this feeling with the different teams. And security is just invest as much as you can, and put as much effort as you can. It's never is going to be enough. So here is Polygon. We have a full team, full security team, just working in that direction. We have a full budget in security, and it's a huge commitment there. And the worst thing is that you never have this confidence, but that doesn't mean that you have to invest as much as you can.
If it makes sense. I guess it would be interesting to hear about like where this space can sort of go, because I know that we've invested a lot of time in developing tooling for PIL and zk assembly, and I wonder, like in the future, do you feel like the burden of auditing will be reduced as we build more tooling? Like, how do we get to sort of a state where we can do more kind of rapid development without as much of a burden on auditing? Do you think that's possible? Should be interested to get your perspective.
I think that toolings are something that needs to be done. I mean, it will never interchange the audits, the review from people, at least in the foreseeing future, I think. But the toolings is a must-have in any case. So because it will help, it will shorten the time of the reviews. It will help a lot of ways. Like, for example, if you can fuzz something, it helps a lot with, in exception that just going through by hands and doing everything manually. But it will never interchange the audits. No, maybe not never, but like near future.
Yeah, it seems safe to say that formal verification for zkEVM is still pretty far away. Or, Alex, maybe not. Alex, anything to add on tooling and sort of automating certain parts of the audit?
Yeah, I think certainly, I mean, the tools we have created were more about transforming PIL to be more readable in certain aspects, and then maybe being able to create some proofs for certain properties. We did initially, in the first engagement, we did try to do that, and you can see some of the results of that in the first report. And this tool is called Prospector, and later we learned that actually Polygon also has a similar inspection tool with a web interface. But regarding, more rapid development, I think what we found generally is, the separation of PIL and zkEVM may have proved to be a tiny bit of a bottleneck, at least for us, because you have two disjoint systems, which then are connected through various paths. And we kind of felt that maybe if there would be, a language in between the two, so you wouldn't have like two separate systems, maybe that would have helped, but it's really hard to tell, at this point. And then I think the other tools which would be useful is more like, IDE plugins to help you navigate the system much better. So one example in zkEVM, the syntax itself, it took, a bit of time to get used to. And as you have generally a lot of utilities, just jumping to utilities and seeing what kind of constraints or registers they clobber, that is like a big question, right? It is really basically like what assembly is with calling conventions, where you have to be aware what kind of pieces could be overwritten, what pieces are saved. And I think some kind of an IDE extension to help navigate these could definitely improve the review process. And then also had to actually generate some of this code. The arithmetic state machine seem to have been generated, by a different piece of code. And if you have such pieces where you can generate the PIL code or the zkEVM code, and you can be, certain that the generator is correct, maybe it is possible to formally verify the generator. That is something which could also reduce the time, to review. But, as it stands today, I think the really big saving grace is the testing suite. But unfortunately, as you see over time in mainnet, no matter how many tests you have, there are always going to be edge cases found. Especially if you look at the precompiles, those are like hotspot for issues. And more complex code-related instructions. I mean, one big one in the past has been return data. And I think these pieces may be even more, complicated in zkEVM, just the way, memory and any of these constraints are handled. So yeah, I would definitely welcome a lot of tooling. And I think over time, we may get closer to have more velocity in reviewing this, but I don't think manual review will ever really stop in any of these systems, because you need to have a holistic view and some intuition into something which may not be a pattern.
Cool. Well, that makes sense. I'm curious, Jordi, about the sort of the upgrade path for zkEVM. So suppose that the EVM on L1 introduces new EIPs, or for some reason we want to change like the hash function in the state tree. How do you see that functioning? I actually, Daniel, if we could also get your perspective on this as well, that would be great. But starting with Jordi, what sort of do you see the optimal path being sort of upgrade in place with a multi-sig? Is it migrating to a new rollup? Like what's sort of the optimal path there?
We are Ethereum compatible, so the idea is, so at least what's in the idea is to be a just upgrade in place. So I mean, just doing some upgrades. Of course, there are some some pieces that could be a little bit complex. For example, mention that if you want to upgrade the hash function, okay, then maybe that would be just a full restate of the system. You can do a proof of state transition. Actually, with aggregation, we can actually build that, but I think this may be wrong. So here we need to see case by case and see what kind of upgrade we do. But most of the upgrades that we have planned, at least in the short run, are going to be just adding functionality, or maybe just adjusting some compatibility issues in the AVM. So at least for a while, it's going to be that way. So the idea is to be as close as possible to Ethereum. So it's just transiting from type 3 to type 2. Ideally, in a year, we should be at type 2 rollup if everything goes okay.
That makes sense. Daniel, anything to add on upgrading rollups?
Yeah, I think most upgrades are fairly straightforward because, well, the ones that would be difficult would be ones that touch state, and like changing the hash function, for example, would be more complicated migration, but others would be fairly easy. And I think it shouldn't be that much work to keep up with changes to Ethereum because, for good reason, they happen very slowly. Yeah, on our side, we've implemented some things already, like BLS, which is not actually, it's still a EIP. It hasn't fully landed yet, but we just have it ready for when that happens. Yeah, but overall, I don't think upgrades will be a big deal unless we need to do something like change the hash function.
Cool. And then I'd like to go off script a little bit and ask. I'm actually very curious on Vitalik's perspective on this. To what extent do you think that it's important for Ethereum to eventually be sort of succinctly verified? And obviously, we're talking about incorporating EIPs L1, L2. Like, to what extent do you think that the future design of the Ethereum L1 should sort of take into account like zk friendliness, and so that we get to the point that we might eventually be able to?
I think that's crucially important. I mean, I think, like I've been talking a lot about the importance of preserving and improving upon the decentralization of the Ethereum network. And I think in the long term, a really important part of the decentralization of the network is going to be just everyone being able to really easily verify the rules of the chain, right? Like I've talked about how I think it should be possible to stake not even just on a laptop, but on a phone. And for something like that to be a reality, like phones are very good at bandwidth, right? But they're very bad at computation. And so, you are going to have to, use something like a Snark or a Stark to replace the computation of verifying an Ethereum block with something much simpler. And the nice thing is that, like, especially with things like PBS and the various stuff that's coming down the MEV pipeline, the computational load of running a node actually should be pretty low. Like, it literally should be possible to make it literally just be verifying once, like downloading a bunch of data, hashing it, and verifying a Snark. And that is to me, definitely a dream long-term future for Ethereum. Actually, if you look at the roadmap, picture that I published on Twitter, I think at the end of last year, in the Verge, after the Virtual trees, the Verge is no longer just about Virtual trees. The Verge is now about verification, and adding I added in a section where kind of the ultimate goal basically is reducing the cost of verifying the chain down to verifying one proof. So I would absolutely love it if the layer 1 could eventually make its way over to satisfying that goal over the next 5 or 10 years.
Oh, Wizard. That's cool. My cell phone is often dead, so I'm sort of terrified of the inactivity penalty if I were to stick from my phone. But I'm sure for more responsible people that would be a very workable model. Well, cool. I think this has been a really.
I have 2 old phones with me that I'm no longer using, so I just put one of those up for staking and leave it at. That's cool. Thing.
This panel has been really interesting, really fun. I guess I think we're right at time, but I guess Jordi, do you want to leave us with a closing thought about security, auditing, zkEVM, and in production?
I would say that especially for the users, just be responsible. It's a new thing. There is many things that can go wrong. So we need to find, we need to be responsible. Of course, we want this to use and we want this to happen. Security is also about people using, and this is how the things get stronger, just having this maturity on the things. But at the same time, we need to understand, and here, so it's important to put the effort to explain to the people that this is a very new technology, that's a very nice technology, it's a very good technology, it's probably the technology of the future, but it's just temporal. So do not go crazy and understand that we are in the early days of this technology and taking account of that. Don't put the money, don't put all the savings and start asking for mortgage and putting the money there. So just things like that.
Cool. Well, great. So over to you.
Well, yes. Well, thank you very much. I thank you all the panelists for this great panel, and also just wanted to say that we encourage collaboration, and I'm happy that Barry actually mentioned that between the zkEVM rollups. Now we leave Brendan and Vitalik in this panel.